Statistical process control is a statistical technique that first originated from Walter Shewhart, a physicist and statistician in the 1920s. Statistical process control, or SPC for short, is a technique that allowed to control a process or production, which in turn made it viable to oversee these different processes or productions and scout for any issues or problems within the system and find a probable outcome for the problem. On the other hand, SPC also birthed a popular tool known as the control chart, which was capable for the analysis of how a process or production changed over time graphically. This allowed the data to be analyzed how many times a failure may occur versus the time, and see when the failures occurred compared to the normal readings. The control chart will always have a center line, which will display the average, and then two other separate lines on top and bottom. The lower line describes the lower control limit, while the upper line defines the upper control limit, both which set parameters where everything found in between will be normal and any outside will be abnormal. With that in mind, we can see that SPC would be very important to engineers that work with processor control. Using SPC tools such as a control chart will allow the engineers to analyze and record a processor production and see what the normal activity would look like, and be able to view when something breaks the bounds into the upper or lower control limits. For example, the production of bolts and nuts on a manufacturing line. Each one will vary and be different, but even with those slight variances, they will still work up into a certain point, where the thread or the length fail to point where they become defective. Simply put, a control chart allows us to see when these defects happen. If 3 samples were taken from the manufacturing line every 3 hours for a machine to measure 10 bolts thread distances. Once all the data is collected from the test, the mean and the upper and lower control limits can be produced. The data shows that on average the machine measured 2 millimeters for the spacing between each thread on the bolt. From there, they were able to calculate the upper control limit of 2.5 millimeters and the lower control limit of 1.5 millimeters. This allowed the engineers to see that any bolt thread with 2.5 millimeter distance or larger would be defective, and likewise with any distance of 1.5 millimeter or smaller. So, in conclusion, SPC is important to engineers as it allows them to test products to ensure they are within functioning parameters, while anything found outside will be considered defective.